Drones are awesome, but they could be even better. Like, they're kind of hopeless in smoke or fog, and they're just so big. I want a drone that fits on my finger like a bug. That kind of thing is exactly why engineers have been turning to nature to perfect drone tech. After all, animals have been flying for more than 300 million years, so they've got a bit of a head start on us. And we can learn a lot from them about navigation, miniaturization, and even the best color to be for optimal flight. It's not hard to imagine a situation where it might be helpful for a drone to have an idea about what's around it. Like, imagine if a drone could find its way through smoke-filled rooms in a burning building. It could help emergency workers save lives by scanning areas where people might be trapped. But smoke makes it pretty hard to see anything because the small particles bounce visible light all over the place. And it's not just smoke. Fog, snow, dust, anytime you have lots of light-scattering particles, it can be pretty tricky to see where you're going. Even some radar gets stumped. So, to help drones navigate these conditions, scientists are studying animals who see with more than their eyes. Echolocators like bats map their environment based on how long it takes a sound to echo back after they make it. Sound is a pressure wave, so it mainly moves through the air around particles instead of getting bounced. But while a couple of scientists have made drones based on bats, bats are pretty hard to mimic. They're smaller and more maneuverable than a lot of today's drones, and bats have evolved a ton of really specialized structures in their brains and bodies that are great for echolocation, but aren't easy to recreate. So another team of scientists looked at oilbirds instead. These South American birds use echolocation to find their way around caves, but they're bigger than bats, and their echolocation isn't quite so sophisticated. Plus, they use their talents more sparingly. When there's a lot of light, they mostly use their eyes. Then when it gets darker, they switch to their ears more and more. And that kind of switching between systems is exactly what you'd want in an autonomous drone. But it'll probably be a little while before any oilbird-inspired drones hit the market. Researchers still need to figure out how the birds' brains combine all this information to create a single picture of the world, because that's what drones will need to do before we can let them fly by ear. Now, one of the upsides to oilbirds is that they're already about the same size as modern drones. But one of the big goals of drone tech is to go small. The problem is, really small drones can't fly on the same way that big ones do. Because physics. Today's drones mainly have fixed wings like planes or spinning blades like helicopters. But once fixed wings and blades get down around a few centimeters long or less, they stop generating the lift needed to stay airborne. Air just doesn't really glide around small things like it does big ones. Instead, it piles up, and little random differences in pressure from one place to another push objects around, destroying any lift they get from moving through the air in the first place. But we know small things can fly because insects exist. And researchers are learning from them how to miniaturize. Insects don't use rotary blades for wings, for example, and their wings don't stay still either. They're constantly flapping during flight, and the smaller they are, the more they flap. Flapping wings are just better for flying at small sizes, where flying depends on pushing against the air instead of gliding through it. So engineers have built little flappy drones modeled after little flappy insects. They're still working on efficient batteries for something so tiny, and they're still trying to make their little mechanical insects as stable as actual insects are. But they imagine a future where tiny drones can do things like precision pollinate crops. We could try to train bees to do that, of course, but it turns out they don't always listen when we tell them what to do. And who can blame them when they look so cool in those classic black and yellow outfits? Though bees do come in different colors, and so can drones. It turns out that different colors don't just make your drone look cool. Studies on animals suggest they might actually help it fly. Right now, you can split drones into two broad color groups, black ones and not black ones. But they should probably all be black. You see, a lot of animals have what's called counter shading. They're light on the bottom because it makes them look more like what's above, and they're dark on top because it makes them look more like what's below. Or so everyone thought. But experiments with models of birds, dolphins, and orcas have all found that darker backs may be more than camouflage. Both in air and in water, they seem to let the animals move with less drag because of how dark colors absorb and radiate heat. They heat up faster from sunlight and transfer that heat to what's around them, which makes the air or water they're in thinner and easier to move through. So if you want a drone that uses as little energy as possible to fly, you should get one that's the color we all instinctively know is coolest: black. Also, if someone ever says you wear too much black, just tell them you want to be more aerodynamic. And the next time you see a tiny black screaming drone flapping its wings above your head, you'll know which human and non-human animals you have to thank for the technological marvel.